Astrophysics, gamma rays, and exoplanets. Oh my. Tonight we recognize Halloween and all things scary as we explore the galaxy of horrors. We're delighted you can join us for a discussion of dark energy, the roasted planet, gamma ray ghouls, and flares of fury. These concepts, frightening as they are exciting. I'm Stephen Jones Jr., the Vice President for Health System Strategy with UTMB Health. This is my partner, Gene, and we sponsor the Thought Leaders Lecture Series. We're happy to have you with us. Tonight's speaker panel includes Dr. Judy Rackison, Dr. Elisa Quintana, Joby Harris, and Caitlin Soares. Dr. Rackison and Dr. Quintana are both astrophysicists at NASA's Goddard Space Flight Center. Dr. Rackison studies gamma ray bursts, the most energetic explosions in the universe, while Dr. Quintana's work examines exoplanets and the characteristics that comprise the atmospheres of these extremely distant planets. Joby Harris is a visual strategist at NASA's Jet Propulsion Laboratory. He's the art director for the upcoming Mars Sample Return mission and illustrates many of the Exoplanet Travel Bureau and Visions of the Future and Travel posters. Caitlin Soares is public outreach lead for the Jet Propulsion Laboratory. Her passion is in using the intersection of art and science to explain complex scientific concepts to the public. This evening, our panel of experts will work to calm our fears about the mysteries and marvels of outer space. While they may have a few tricks up their sleeves, they will instead treat us to an outstanding presentation. Gene and I thank you for joining us and enjoy the lecture.
Hello, I'm William T. Harris, President and CEO of Space Center Houston, a dynamic science and space exploration learning destination and nonprofit science center. We also have the privilege of serving as the official visitor center for NASA Johnson Space Center. We share the story of human space exploration, past, present, and future, with more than 1.25 million visitors annually from around the world. Our purpose is to bring people in space closer together. Thank you for joining Space Center Houston's Thought Leaders Series program, Galaxy of Horrors, presented by University of Texas Medical Branch. Our Thought Leaders Series brings you space and science experts from across the country who provide insights and perspectives on space exploration. Space Center Houston offers robust learning experiences that enable you to be part of NASA's mission. In addition to our extensive collections, you can experience new exhibits and live programming, so there's always something new. Now on to our program. Art and science converge in NASA's Galaxy of Horrors, posters based on real NASA science. The fun and creative posters are based on real phenomena, the cosmic web, gamma ray bursts, dead stars, dark matter, and more. The posters were produced by NASA's Exoplanet Exploration Program Office, located at NASA's Jet Propulsion Laboratory in Southern California, with the input of astrophysicists. Posters are created in both English and Spanish. There are two new additions to this year's Galaxy of Horrors that we're going to get to see, Dark Energy and Roasted Planet. So now on to our program. I'm delighted to welcome our panelists. Our first speaker is Dr. Judy Rackison, who is an astrophysicist at NASA Goddard Space Flight Center. She works on current and future NASA gamma ray missions, including as a deputy project scientist for the Fermi Gamma Ray Space Telescope, and as the Deputy Principal Investigator and Ground Systems Lead for the Burst Cube CubeSat mission scheduled to launch in 2023. Our second speaker is Dr. Elisa Quintana, who is an astrophysicist at NASA's Goddard Space Flight Center. She's worked on a variety of space missions, including Kepler, K2, TESS, and the Nancy Grace Roman Space Telescope. Dr. Quintana is currently the Principal Investigator of the Pandora SmallSat mission, which seeks to characterize the atmospheres of planets orbiting distant stars. Our third speaker is Joby Harris, who is a visual strategist at NASA's Jet Propulsion Laboratory, where he supports scientists, engineers, and their missions with artwork and design. He was an illustrator for many of the Exoplanet Travel Bureau and Visions of the Future intergalactic travel poster series, and is currently an art director for the upcoming Mars Sample Return mission. Our fourth speaker is Caitlin Soares, who is the public outreach lead for astrophysics at NASA's Jet Propulsion Laboratory. She presents data through a creative lens, making complex scientific information accessible to wide audiences. Caitlin is passionate about exploring how the convergence of art and science can serve the public. And now on with our program. We'll first hear from Judy.
Hi, I'm happy to be here today to talk about this fun and creative project mixing science and new creative accessible ways to visualize that complicated astrophysics in a fun art series. I study the most energetic explosions in the universe, gamma ray bursts, and I'm happy that I was able to contribute what it might look like to bring those to life for an unfortunate viewer nearby. I think it's great to find creative ways to engage the general public with the science that we do at NASA. One of my personal outlets is I do a lot of astrophysics related baking, which is regularly featured on NASA Universe social media. So I hope you have a chance to also check that out.
Next, we'll hear from Elisa.
Hi, I'm really excited to be here to talk to you all about the science I do. I study exoplanets. These are planets that orbit stars outside of our solar system. We now know of over 5,000 planets outside of our solar system, and they are so incredibly diverse. And so it's really fun working with artists to try to visualize what all of these different worlds might look like.
Next, we'll hear from Joby.
Hi, I'm Joby Harris. I work at the Jet Propulsion Laboratory in California as a visual strategist. And that just means that I support the different missions and the different projects with design and artwork, not only for outreach like these posters, but also internally during mission formulation, project formulation as well. So surrounding all phases of a project or a mission, but I'm really excited to talk today about these Galaxy of Horror posters.
Thank you so much, Joby. Thank you for your creative interpretation. It really helps people understand exactly what is out there. And we'll hear from our first speaker now, Caitlin.
Hi, everyone. I'm Caitlin, and I love talking about connections between science and art. As William mentioned, I managed communications teams for museums in New York City and Boston before coming to NASA's Jet Propulsion Laboratory. And I started working at NASA JPL in 2018 because I was actually inspired by all of the work that their public outreach teams did. And now I work in NASA JPL public outreach as well. So it's kind of been a full circle journey for me. But thank you for having me. I'm very excited to speak with you all today.
Well, I'm excited now that we're going to jump into our topic and see how these illustrations help us better understand or get excited about exoplanets and really understanding better other celestial bodies in our solar system and beyond. First, we're going to hear from Joby and Caitlin.
Sure, I can kind of give a background as to how this poster series started. So in a way, the Galaxy of Horrors series was born from the success of another poster series that really helped put exoplanets on the general public's map. That was called NASA's Exoplanet Travel Bureau. The art in those exoplanet travel series posters, many of which were actually illustrated by Joby here, visualize how travel to exoplanets or planets outside of our own solar system, as Elisa said, could be appealing to future explorers. As a communications and outreach team, we're always thinking about how to best engage the public in NASA science, including on holidays like Halloween. So the birth of the Galaxy of Horrors poster series happened when a colleague of mine started thinking about how we might take a different angle on artistically engaging the public with our science. But instead of picturing space as a travel-friendly frontier, how might we highlight some of the more dangerous, horrific things that are lurking in the cosmos? So that's how the concept was born. We decided to illustrate the Galaxy of Horrors series in the style of B-movie horror film posters, which Joby will talk a little more about. And we've since been featuring them year-round, but especially during Halloween. This poster series was also unique in that it was one of our first products that we released in both English and Spanish at the same time. Another important consideration when we were creating this series was to keep the artistic style consistent with the exoplanet travel posters. My colleague Joby, who's also on this panel, illustrated the first few I mentioned that we created and has also served as art director on many of the more recent horror posters, so he can speak a little bit more about that process.
Thank you, Caitlin. Yes. So as Caitlin mentioned, I had previously illustrated several of the exoplanet posters. So they kind of wanted to bring me in again, being that I'm familiar with the process, because it is kind of like a dance when you're working with the scientists with these posters. I'm introducing aesthetics and visual design. They're introducing science, so we got to get that right. And so it's quite a unique process, which we'll get into here in a little bit. But I jumped into this project for the Galaxy of Horrors with a lot of excitement, because I knew that we were going to have fun, like a lot of fun in a new way this time. So as they began to pitch what these first three posters would be, I think we settled on zombie worlds. I think it's PSR B1257+12. It's the undead stars, right? And then also another planet where it rains glass sideways. So dangerous stuff, creepy stuff. So it was a lot of fun to sort of dive in to this 50s B movie style. And the reason I say that is because as I did research, I didn't think anybody was really harnessing that genre in a spoof type of way. And I thought it'd be fun to just go that direction, because it's very wall worthy. And that's ultimately the goal, right? We want whatever we create to warrant a place on someone's wall, in their home or in their office. Because if that happens, then NASA in astrophysics and science is going to be in front of someone daily. And that is just prime real estate. So we wanted to do this sort of B movie style. And what we discovered was, in that style, we were able to have fun with the titles. So any way that we could bring science in, right? So again, just sort of, we call it kind of sneaking up on learning. We want to present something to someone and they'll be like, wow, what is that? And then they like it, and then slowly they get pulled into some deeper things, to understanding deeper ideas and complex. I mean, there's nothing more complex than astrophysics, right? So how do we really kind of unfold that in a beautiful way? So we found that with the titles on the posters, we could not only fit the science in the fun title itself, but also in the fun 50s B movie over dramatic subtitles. And then also we were able to work even more complex science and descriptions on what was going on in these posters in what looked like movie credits, basically movie poster credits, where we were able to kind of make certain science words look big, like in the names. Names of stars would actually be, whatever the science was going on. So as we did these posters, we were like, wow, this is a lot of fun, and it sort of writes itself. And so immediately after we did these first three, they were pretty successful, and we were like, oh, we got to do more. We have to do more. And fortunately, there was no shortage of astrophysics out there that is creepy.
Thank you, Caitlin and Joby. This is absolutely fascinating, because I love the fact that you are taking a really popular subject matter, or culturally appropriate subject matter, and I'm really curious to understand how scientists feel about this and how they view it. And I think now we're going to hear from Judy and Elisa to kind of provide us with the science context for creating these images.
Yeah, so we're going to start with this fun little guy depicting dark energy. Dark energy is a mysterious, repulsive force that has huge effects on the universe that we can observe, but we're really only just starting to understand the cause of it. Everything that we know that makes up humans and plants and animals and Earth and other planets and stars and galaxies and particles in the universe actually only accounts for a very small fraction of the total energy in the universe. It's called visible matter. It's about 5% of the total universe. But 27% of the total energy in the universe is dark matter. And we have lots of theories of what causes that. In fact, there's another poster we're not going to talk about today in this series that depicts dark matter. The rest of the energy in the universe, the 68%, is this mysterious dark energy. So if all of the energy in the universe was just this matter, even all of the normal matter, the visible matter, and the dark matter, the universe would eventually stop expanding and collapse on itself, or maybe just continue expanding forever and maybe coast in its expansion. But what we actually observe by measuring distant objects and independently, like how we can measure their distance moving away from us, is what we measure is actually that the universe is accelerating. And the acceleration could only be caused by this mysterious dark energy. And Caitlin's going to tell us about how that's depicted in this poster.
Thanks, Judy. Yeah, so when we were originally concepting how to portray dark energy as a scary movie poster, I mean, we had this long list of, we were writing on a whiteboard, we had this long list of different ideas, but the one that we kept coming back to was the idea of a vampire bat, which you can see here in the poster. And as Judy mentioned, this, relentless energy that's kind of pulling the universe apart at a quickening rate, which is, I think, even scarier, will eventually offer a bigger fright, which is that our galaxies over time will move farther and farther apart over trillions of years, leaving the universe to an inescapable freezing death in pitch black expanseness of outer space. So it's pretty horrifying if you think about it. But we didn't want to get too scary, so we settled on the idea of something a little more relatable, a bat that is lurking in the cosmos, and we kind of hid it in the art of the poster a little bit and left it up to the imagination of the viewer. But if you think about a bat flapping its wings, we symbolize dark energy through the void of the bat flapping its wings in this poster. So we stuck with kind of ghoulish Halloween color theme here. We went with the bat. This has proven to be a really difficult thing to artistically portray, but I think we did a good job in working as scientists and communicators and artists on talking about dark energy, and as Joby mentioned, using the credits to educate viewers on what this force actually is and how it will influence the ultimate fate of the universe.
Yes, I'm really excited to talk to you about one of my favorite systems. This is a planet orbiting another star called HD 80606. And what makes this planet stand out amongst all the other planets that we know of is how extremely eccentric its orbit is around the star, and I'll explain what that means. And so we have many planets that go around their stars, like in a circular orbit, like you see here, Mercury, Earth, and Venus. This planet has a really, really oblong orbit. And so what that means is it spends over 110 days going around its star, but it spends most of the time going far away from it. And as you can see here, as it comes very close to the star, a lot of exciting things happen. So within only a matter of 20 hours or so, this planet goes extremely close to the star, and what that means is that it causes its atmosphere to make very rapid changes. So if it's coming from the extreme cold space, coming around its star really quickly and increasing to a really hot temperature, modelers are predicting that this could cause clouds to rapidly form and maybe disperse. Some people predict that you might be able to see some of these weather patterns with some of our future telescopes. And so recently, this planet was discovered to transit its star with the Transiting Exoplanet Survey satellite. So this is one of NASA's smaller missions to observe exoplanets as they cross in front of their star. And so this spacecraft TESS was able to see this planet cross in front of its star several times. And so that allows us to know the times it's going to cross, so we can use other instruments to observe it. And so what is really exciting is NASA's James Webb Space Telescope, which just recently launched, does plan to observe the star in the very near future. And so what we're expecting to see is any signs that we can see the atmosphere changing during the very close passage of the star. And this will allow us to really understand a lot of the atmospheric dynamics, if we see cloud patterns, a lot of things that we can't really see on other worlds. And so a lot of people are really, really excited about this star. And I love the interpretation of this because, we don't have that many planets in these types of orbits. And so I think the artist did a really good job at translating, the sort of extremeness of the system here on this poster.
And I can add from the communication side, as we were working on this specific poster, something that really struck us was about the uniqueness of this planet was the extreme weather events caused by the elliptical orbit. So one thing that you'll see if you stare closely enough at it for enough time is that there are many faces screaming in this exoplanet, representing the howling wind storms that happen when this passes close to its star. And it's also noted in the tagline there, "Can you hear this exoplanet screaming?" And Elisa made a really good point that these posters also help promote a lot of the missions that are doing the science, a lot of the NASA missions, space telescopes that are doing the science portrayed in the posters. She mentioned TESS, one of our exoplanet space telescopes. Spitzer, the space telescope that recently retired in 2020, also studied this planet. And then we actually released this poster before the James Webb Space Telescope was launched. So this poster, in a way, also served as an exciting promotion for the exoplanet science to come out of the James Webb Space Telescope. And there will be observations happening of this planet.
This next poster depicts the biggest, scariest, brightest explosions in the universe, a phenomenon known as a gamma ray burst. This type of gamma ray burst is produced, one type is produced by the merger of two neutron stars. These are dense stellar remnants left over of a system that contained two massive stars that probably about 1 billion years ago went supernova. They survived in their binary and they gradually got closer and closer together until they merged together and produced an amazing light show. This is an animation that describes exactly what I just said. And as these neutron stars inspiral, they produce gravitational waves, which are ripples in space-time itself. Then it merges together, produces these massive jets that then start interacting with their surrounding environment, and then produces a cloud of material, which generates some of the heaviest elements in the universe. That includes gold and platinum and uranium. All these things we find on Earth came from an event like this, from a neutron star merger. In 2017, we discovered an event just like this. The Fermi Gamma Ray Space Telescope, which regularly detects gamma ray bursts, in fact, it saw one this morning, was looking at the sky, and the gravitational wave detector, LIGO, was also just monitoring for the signal of these in-spiraling massive objects. And coincidentally, they detected the same event 1.7 seconds after these neutron stars merged together. Fermi detected this little signal of a gamma ray burst. This set off one of the largest observing campaigns with space and ground-based telescopes from all over the world over the following days, weeks, months, and in a couple of cases, years of observing this event, from radio to optical to X-ray to high-energy gamma ray. In the poster, this depicts some very unfortunate visitors that maybe hypothetically could have been nearby in this system. I certainly wouldn't want to be them, but it would have been an amazing light show for the brief fraction of a second that they lived on this remnant of a planet before the gamma ray burst did its thing.
And this is all just unbelievable information. So that Judy just shared about really what's going on here. If you can imagine being an artist, right, an illustrator, where most of your work is for soft drinks, or magazine, articles, and then to suddenly listen to that kind of information about what it is that you need to actually draw. We brought in an outside artist, an individual named Shan Jiang, who does everything by hand, by the way. So this ended up being one of my favorite pieces of art, because you can zoom in on everything in here and see incredible amounts of detail on every inch of this. So the big challenge with this poster was how, it's so beautiful. There's so much going on. How do we get the title in all the science on there somehow? But I do want to kind of bring up again that one of the most exciting things in terms of the process of the creation of these posters was being able to bring in some really talented artists from the outside, but also having these meetings, right, where we connect the artists to the scientists. And they're literally, if you can imagine the artist sitting down and hearing everything that Judy just shared, and their eyes are just huge, and you can't tell if they're just like, mummified from fear of having to try to get all of this into a visual form, but what ended up happening was they were like, this is the greatest project of my life. Like they dreamed about something like this. So it was a lot of fun to share the science with them, and then really let them go off and sketch and come back with artwork. And surprisingly with this one, we had a major change to it in terms of, how everything looked when they collided, where the beams went, so it didn't look like it was annihilating the people in there, right? We still wanted it to be fun. We didn't want it to be incredibly violent, but as she just shared, like, I wouldn't want to be near that thing. So we had to put people in there, right? So here's the other thing that we run into with these types of posters, is the technology that's shown, right? So before we were kind of given not some warnings, but rightfully so, any kind of depiction of technology in these posters that had a NASA meatball stamp on it, to some people may have been like, NASA's going to build this, like, here's the design, they're going to make this. So that actually, the way that we got away with some of this stuff is, you can see there's a vehicle, like a fun vehicle there, driving around this thing. And then the artist actually went a little nuts and had the astronauts carrying these giant ray guns, like, so we had to, hey, no guns, get rid of the ray guns. But the more fun we got with the 50s sort of style, the more that we were allowed to do some of the technology, right? Because it is so ridiculous that it just sort of fit in that genre. We had to stay in that genre. That allowed us to do some technology, like the vehicle there. So we did have to kind of tame some of the fun that the artists were having in terms of the retro vibes and feels, kind of taking away certain things. But all in all, they had a lot of fun. But I will say that this poster was a little bit of a challenge getting all the science on there, because it was so beautiful. We really knew that we had the bottom corner, So I think we went through a number of iterations on how can we get as much science in the credits here and the subtitles as possible, and just let the art breathe. But I really recommend looking at this one, just zooming in on the details, as it's quite beautiful.
Well, I wanted to jump in to ask, because these are spectacular, and Elisa started to mention a little bit about James Webb Space Telescope, and we're all beginning to see these amazing representations of the images. Are these beginning to inform how you're depicting some of the exoplanets in both your artwork and in other illustrations?
I can answer that. So NASA's exoplanet exploration program is located at the Jet Propulsion Laboratory, and part of the work on the outreach team that I work on is creating, animations and illustrations that are more technical, and it can be used in, for example, press releases about exoplanetary discoveries, etc. I definitely think that we take more of an artistic license in the posters. And that's kind of, our playground where we can be more experimental. But when we are portraying exoplanets in more technical ways or more official media-centric releases, we do tend to stay more technical. Occasionally, we'll throw in one of these posters which offers a more artistic representation. But yeah, we usually keep those a little bit separate, the outreach and the more technical ways that we portray exoplanets are informed with each other, but still stay pretty separate.
So I was curious about something, Joby, you said about undead planets. What does that mean, an undead planet? Or anyone else who would like to respond to that?
Oh, if I said undead planet, I meant undead star. So that would be, I'm looking at the poster right now. Let me see if I can grab it. So it's this one, it's Zombie Worlds, right? So this one is highlighting Poltergeist, Draugr, and Phobator, right? So those are bad guy names that we've seen probably in movies, all taken from this. But yeah, this is one of the first posters. The planet's caught in the horrifying grip of an undead star. So I will let the scientists really answer what is going on here with an undead star. But this is one of our first posters that we experimented with. In could we do a skull? Could we make a skull? Could we get away with doing a skull with this type of stuff? So there's a little bit of a risk, a little bit of an experiment, but some of them wrote themselves. So as an artist, when you're told, hey, this poster is going to be about planets caught in the horrifying grip of an undead star, you just start to go a little nuts in terms of imagery, and then you let the powers that be maybe kind of scale it back a little bit. But this was, we did do kind of a skull shaped by stars and systems and light, and And so that's part of the fun as an artist, is that I'm also learning. I'm also trying to figure a lot of this stuff out. I'm having great conversations with the scientists. So I'll let the scientists answer on what the deal is with an undead star.
So we're really finding a diverse set of exoplanets around all types of stars. So we're finding planets around stars like our sun, and everything from, really exotic stars, beyond our solar system. This next one is a really young star. And so it's a really well-studied star called AU Microscopy. And so we have a star that's really young. It's about 22 million years old. And while that seems really old, if you think about the age of our sun is 4.5 billion years old. So in cosmic terms, this is, like a baby star. And it's known to have this vast disk of gas and dust, which we think is a signpost of planet formation. And so we've seen many images of this disk. What is interesting is the disk that we see in the sky is pretty edge on. And so it's in a perfect configuration to look for any planets that would cross in front of its star. So using the technique that the TESS mission uses to find exoplanets, for example. And the graphic on the right is a couple of screenshots of where you can almost see some clumps of material moving through the disk. And so this is almost like a perfect lab to study planet formation around other stars. And one of the most exciting things is that the TESS mission recently observed the star. And so a lot of people were really excited, because we thought if it does have planets, then we would see them transit. So here I wanted to show what real data looks like, and this is the type of images where we get all of our information to feed to the artists. And so I wanted to highlight some of the information that we get out of this is the TESS mission. You can see the spacecraft right there. And what TESS does is it essentially looks at the brightness of a very distant star over a really long time. And so what you can see in the top plot is you can see all these wiggles, and what those are caused by are we know the star is covered in many spots. So we have dark spots, and so as the star rotates, the brightness is going to go up and down. So that is showing us that we have a very spotty star. And what that means is that this is a really highly active star. And so it's going to have really great giant flares and a lot of radiation that is spewed out. And so what we do as scientists is we are able to remove this predicted signature, these wiggles, and then you can see right underneath that these great big spikes. And so what those are showing are stellar flares that basically the star is spewing high energy radiation pretty frequently. So this is just about, 20 days of data. And then another thing we can see is signatures of planets crossing in front of the star. And so we were really excited that TESS was able to capture the signatures of 2 planets orbiting AUMIC. And so those are showed in the lower panels. You can see the dips. This is basically, looking at a star, and when the planet crosses in front of it, it blocks a fraction of light, and then it moves out. And so you see these dips. And so this whole system of AUMIC is really, really remarkable. We have a star that's young, we have a disk, it has planets, it has flares, and it's a really hostile place if you were going to live there. And I just wanted to show to scale. This is a fun graphic that shows the size of a solar flare from our sun, and if you were to bring the Earth all the way in very close to the sun, you can see the difference in the magnitude. And so how big these flares are just from our sun. And our sun is considered a quiet star. And so if you think about the AUMIC system, we have planets this close, but the flares on AUMIC are almost 100 times greater than those from the sun. And so you're getting this planet that's getting constantly scorched. And so it's this really, really amazing system that we had so much data to hand to the artists, and it was really exciting to see what they came up with, which I think Jovi is going to talk about next.
Yeah, helping. So I actually illustrated this poster, and this was a lot of fun to kind of sit in the room to receive all the science that a lot of you just watched. But my head is thinking aesthetically, you can put a lot of the science and data on paper and hang that up, and a very select few will understand it, and genius people will look at that and find it fascinating. So I was trying to think the whole time how to take that, the amazing data, especially that last one where the flare was just overtaking that tiny Earth, and okay, so if I put a camera on that planet, what is all that going to look like, and how do I get that aesthetically pleasing to a wall? So normally a process will be that I'll meet with the scientists, we'll talk through, they'll show me the data, and then I'm literally sketching in front of them. I'm kind of drawing, and I'm a little bit traditional, so I use like black pencils or markers, and I'm just kind of drawing in front of them, and we're kind of piecing together some visuals. I'll then go back and refine the sketches, and I'll actually do what are called color comps. And I'll start to kind of add color very quickly on some of these ideas and sketches, because I, as the artist, as an art director for these posters, and then even as with the series, I have to think about, we want people to hang up more than just one of these, right? So they have to actually look good as a family. So fortunately, we didn't have too many posters that were involving scorching red colors. So we were good on that. I knew I was going to use yellow and orange and red, and then I knew that was going to be kind of a dominant part of the poster. So I, as the artist, will sit down, talk with the scientists, do sketches, I'll do color comps, and then I'll go back to them. We'll actually have another meeting where a lot of the science is actually refined. Well, if there was a planet there, you would maybe see a lot of the debris coming off of it, just to accentuate that this thing is just shooting these flares out in a directional way. Another thing that we start to work on is actually something that Caitlin really is really good at kind of handling as a project manager is the copy, all the wording, not only the science, but we get to use fun titles like, the terrible tantrum of this star. So a lot of that language comes out when we talk with the scientists, and we sort of go, what is it exactly doing? Well, it's having a tantrum. Like a little kid just throwing a temper tantrum, and then we hold on to words like that as our big sort of dramatic subtitles. Beware of this. It's terrible. It's a terrible tantrum of this angry young star. So a lot of that work is done by like Caitlin, along with the scientists, to really pull out those dramatic words. You'd be surprised too that we create a massive list of synonyms. Like, should it be flares of fury? Should it be flares of something else? We actually kind of talk through a lot of the copy on those words. And so as we went on to some of these later posters, all of the titles, all of the words have already been worked out and figured out, and then we kind of throw that to the artist. But I remember with this poster specifically, we were really having a lot of fun trying to figure out what these titles were. And then we also, kind of highlighting the telescopes, as was said earlier, as if they were stars. I think this is the first time we were like, starring this, this particular telescope. In this case, it was Spitzer. So I think this was also a preempt to, the telescopes kind of need their own posters, from here. We got to really bring a lot of great attention to the telescopes themselves. So anyway, just giving you a little bit of light on the process of how these things are made and how great things can be discovered in the process to say, hey, we need to do a series like this over here now.
Well, I imagine you must have physicists and other scientists knocking down your doors to come work on different types of illustrations.
Yes, we do. And, I work in a little design studio of about 6 or 7 other people. It's called the Design Lab. And actually, the need for posters is almost more the introduction of the scientists coming saying, hey, we want posters. And so as a designer, I'll go, well, really, is it posters, or do you want something else? And we'll kind of figure out. So it all kind of goes to, what do you want to say? What do you want people to walk away with, and understanding your mission and your instrument and what it is that you want to do? But to be honest, the introduction is, I want posters, I want stickers. And so a lot of times we do give them that, but it is the doorway to a deeper conversation of let's really look at what it is that you need.
And I can add on to that. So, even though these posters that you're seeing today have been produced out of NASA's Jet Propulsion Laboratory, we're managing the process. I'm kind of project managing the artists, the art directors, the scientists who are involved. We take great strides in trying to incorporate scientists from other NASA centers. You know, JPL is just one NASA center, and there are many others around the country. So Elisa and Judy, for example, are in Goddard. And so when we knew that we were going to be making a lot more scary exoplanet posters, a gamma ray burst poster, we knew that we wanted to involve them from another center to get their perspective from where not only where they work professionally, location-wise, but also their expertise.
Well, it's actually fascinating that you're working with scientists from other centers. And so I guess, Judy and Elisa, how did you react when you were first approached about being part of this project?
So when I was first approached about this, I thought it would be a lot of fun. I mean, I'd seen those exoplanet travel series posters, and they really strike the imagination. And I was excited for astrophysics to get something nearly as imaginative, for a series depicting some of the really fun and scary objects in the universe that produce some of the universe's most amazing light shows. So I thought it was a really interesting project. I like working on outreach, and I contribute for the Fermi mission to the outreach we do on behalf of the mission. So I thought it was a really fun opportunity, and it's been great that we've been able to not just collaborate on these posters, but continue to talk about them in venues like this one.
Yeah, I'll also add that I would say this is one of the more fun parts of our job too, is working with people who can help us, disseminate the information that we're doing. Because a lot of, at least the missions I work on, like tests, we get images of pixels. We don't get these beautiful graphics like the James Webb Space Telescope was telling us. And so being able to get the public excited about what we're finding, is really important. I was already a fan of this group of artists. I think Joby worked on one of the planetary systems that I worked on, Kepler 186f, and those were wildly popular. And so when we were told that there was going to be a series and one focusing on AUMIC, so many people were so excited because it's such a unique system. And so it was really fun. Sometimes getting out of the daily grind of working on programming and your laptop, and coming and being able to bring a group of scientists together and say like, oh, well, the perspective from this planet would probably be a little bit different because we're further out. And then in real time, Joby would just like redraw the flare. It was a really, really fun time. And so, yeah, I feel privileged to be able to work with people who can, show how cool these systems are.
So Caitlin and Joby, do you have other Hall of Horrors candidates that you're looking to develop and add to the series of posters and images?
Yeah, I can. We definitely want to expand it more. I think it's not a question of, oh, there's just nothing left to pick. It's a question of there are so many scary things in the universe. What is our next choice? We will not be releasing one for this Halloween 2022, but we are thinking about having some more in the works for next year. Some subjects have been thrown around, like inflation, for example. Inflation is the very short period, like fraction of a second of time, where the universe expanded so rapidly after the Big Bang. So we're thinking about how we could potentially make that into a scary poster. There's some other ideas being thrown around as well, but to see what we currently have, I'd encourage everyone to go to exoplanets.nasa.gov, look at our Galaxy of Horrors series there. We have a black hole one, we have a dead galaxy, which is actually a galaxy that Hubble observed. So there are examples of what exists there, but we are open to suggestions. If any members of the public want to get in touch for some scary ideas, we'll definitely accept those. Yeah, we're thinking. Joby, do you want to add to that?
Oh yeah, I was going to say the public and had a lot of great suggestions in the posts whenever they're released to the public, and I don't think the universe is short of things that are mummified and dead and floating and causing havoc out there. So as long as we don't run out of analogies and synonyms for our copy, I think we're going to have lots of great stuff in the future.
Well, I wonder if anyone would submit. I know it's not quite Galaxy of Horrors, but the recent DART mission where we diverted an asteroid could be a really interesting one for Galaxy of Horrors depiction. So I'm curious for you, for Judy and for Elisa, do you have some favorite exoplanets that you'd like to have featured in a poster series?
I feel like that's like choose your favorite child. They're all so wonderful. We're really, I mean, one of the interesting aspects of the exoplanet field is it's progresses so rapidly, and so just a couple decades ago, we thought we were trying to see if Earth was common, if things like what we see in our solar system are common, and what we're finding is basically all over the map. And so we're finding small planets, big planets, old stars, new stars. We're finding planets around stars that are older, almost 12 billion years old, like so almost the age of our solar system, and then all different types of architectures. And so I think the possibilities are endless. And also I think what James Webb launched, one exciting thing about these big flagship missions is we don't know what we're going to discover. And so I expect a lot of really fascinating new systems to be revealed. So if I had to pick one, it would be really hard.
And how about for you, Judy?
Sure. So my area of expertise is not exoplanets. In fact, most of what I know about exoplanets is from hanging out with friends like Elisa. But my area of expertise is astrophysical transients, which constitutes black holes, neutron stars, objects with extreme gravity, extreme magnetism, extreme energy producing. So there's a lot of different types of transients that I could imagine would be fun. Fast radio bursts is a relatively new type of transient that we're just starting to learn what causes them. They have a really short, tiny burst of radio waves, and we're starting to see that there's some counterparts in other wavelengths. Pulsars are a bizarre type of neutron star that spin crazy fast, like the speed of a blender, but it's several times the mass of the sun. That would be a fun one. And there's a lot of other unique systems that we see that in our galaxy and out to the edge of the universe that I think are plenty scary and would be fun to depict in this series.
Oh my goodness, you listed a lot of things I hadn't even imagined with great description. That sounds really fascinating. Well, I have to say, I am so interested in all the things that you're doing. How did you each get into what you're doing? Tell us, because many of our viewers are youth and they're looking at their careers and their paths. So if you could each just share a little bit about how you came to do what you're doing and kind of what drove your passion. Maybe we'll begin with Elisa.
Yeah, so I was sort of a late bloomer. I didn't decide until I was actually at a community college that I wanted to go into science. I talked to a lot of people at NASA who say they've known since they were 5 that they wanted to be an astronaut, or they had parents who were professors or something. And so mine was pretty random. I, kind of never crossed my mind. I grew up in a really small town. And, I think once I started on the path of studying physics, I just got really interested. It was challenging, and then I ended up doing astrophysics. And so, mine was kind of a non-traditional path, but I also do really like that I can, tell people that it's never too late if you want to study astrophysics, because there's a lot of people I see these days that have, non-traditional paths, and there's so much out there to be discovered. So I would encourage people to get into it, no matter, what stage you're in.
And Judy.
Yeah, so I suppose I was just a nerdy kid who really liked sci-fi, and I liked, at some point I realized that it was like the science that really fascinated me, and kind of the imagination about, how do things, how does the universe work? Yeah, how do stars work? And I was decent at, at math and science, and I went into undergrad knowing I wanted to study astronomy. I certainly did not conceive of how much physics there really was in astronomy, and 4 years later I had a degree in physics and astronomy, and I went on to grad school. But for me, what really made me realize that I wanted to and I could become a scientist was getting involved in sort of summer research projects and doing research as an undergrad. NASA does offer lots of internships at all of the different NASA centers. which is a great kind of opportunity. I didn't do one of those specifically, but that's exactly the kind of program, because I realized that, doing research is very different than taking courses. It's a lot about learning how to write computer code, which is a useful skill in life anyway. Seizing those opportunities and, just see what happens and what you enjoy. And I guess that's how I ended up where I was. And even within, the subfield I went into, I went into grad school for my PhD, not really knowing what I wanted to study. And at the university I was at, they operate a NASA mission, and they were desperately looking for people to work on it. And I said, well, that sounds fun. And, here I am almost 2 decades later, and it's all worked out really well.
And how about for you, Joby?
For me, I was not very good at school. I'm just going to throw that out there. In terms of math and science, my mother, bless her, she saves everything. She kept one of my old math tests once and showed it to me, and it had a big old F on it, So she reminded me that it was math and science, physics were not strong subjects for me, but I was always an artist. My dad was an art teacher, so I was always drawing and always learning how to communicate through visuals growing up. And so I actually come from the film industry. So I was a production designer, I was making props and special effects, and got into directing, started creating more media that way. I wasn't very good at freelance. I was always worrying about where the next job was going to come, what the next project was. I worked on a lot of stuff I didn't care about. And so I knew I needed something a little more stable. And I got the call from the design lab at JPL and said, hey, we need an artist that can handle a lot of different things. They can draw, can do graphics, can build things, build models of things, and to help communicate. So that was 10 years ago that I got hired. It's now been 10 years, and I've been able to apply all of my artistic skills to help communicate, visually in all ways, from traditional three-dimensional objects that go out to schools, to graphics, to illustrations, to even videos and films. And so I never thought I'd be here, but I've had a lot of catching up to do. I've been reading a lot of physics books, a lot of understanding space. So I had a lot of catching up to do to just simply understand what folks like Judy and Elisa are talking about. So yeah, never thought I'd be here, but it's certainly paid off.
Well, that's fascinating. And how about for you, Caitlin? You shared a little bit in your self-introduction, but tell us more about your background.
Sure. I think, honestly, the visual beauty of the universe is what really hooked me. I think I was maybe 5 or 6 when I first saw the moon and the planets through a telescope, and those views floored me. And I was, my perspective really expanded even at that young age. But from that moment on, I was really hooked, and I wanted to work at NASA. But for a very long time, I thought NASA only hired people who were good at STEM subjects. I like Joby, I respect science, I admire math, but I am not naturally inclined in those subjects. But luckily, through NASA's outreach efforts, which I mentioned a little bit before, I discovered that art and science are not mutually exclusive. NASA hires artists and designers like Joby to tell our stories visually and beautifully. And now I'm fortunate to go to work every day, and I'm really excited about sharing the beauty of the universe with everyone.
Well, thank you all for sharing your stories. And I think that's so important for people to know that it takes a whole variety of skills and abilities to represent space exploration and to advance exploration. And that's something we're really committed to at Space Center Houston. We say to youth, well, you may be a fashion designer. Maybe you're going to work on the design of spacesuits, or you're someone. Food science is really critical because we can't survive without good nutrition, and understanding what that is. And also just being able to depict what we're trying to understand, especially when there are things like black holes or exoplanets that are hard for us to physically see. And so I really admire all of you and the work that you do. And thank you so much for being part of our Thought Leader series, Galaxy of Horrors. It's been fascinating hearing from each of you in the roles that you fulfill. And I absolutely love the posters. We've got to put some of those up at Space Center Houston. So again, I want to thank all of our speakers for being part of our program today. And I hope everyone will check out their images on the nasa.gov website to learn more about this incredible imagery and depiction of our universe and beyond. Thank you for joining us.
night sky full of stars. For eons, human beings have gazed up at its tranquil beauty, taking solace in the peaceful stillness of this vast and eternal cosmic cornucopia. And yet, all the while, lurking beyond our solar system among the billions of stars and the exoplanets that orbit them is another sort of Milky Way altogether, a far more sinister space. A place only sophisticated space telescopes and imaging processes can reveal. A place of unequaled terrors. Come with us now, if you dare, and discover the Galaxy of Horrors. Feel the rains of terror, the killer you never see coming. With winds of up to 5,400 miles per hour and torrential rains of glass blowing sideways. The weather here is deadly, and don't let its cobalt blue color fool you. This hazy, blowtorched atmosphere is riddled with silicate particles, making this an unearthly death trap no mortal would dare want to face. Or discover the zombie worlds that exist in this most inhospitable corner of the galaxy, the Poltergeist planet. One of 3 dead planets shambling through the twisted magnetic fields of their corpse star Lich, which is itself the collapsed core of an exploded star. But despite its demise, this undead star spins twin beams of radiation that could incinerate a spaceship foolish enough to venture too close. Even if you could make it to the surface, your nightmares would continue as the radiation from the zombie star rains down on planet Poltergeist, as well as her neighboring dead worlds of Draugr and Phobitor, creating sickly irradiated auroras to light up your certain death. These are just a sampling of the terrible, unwelcoming worlds that inhabit our Galaxy of Horrors.